we're going to learn about mesh current analysis. Mesh current analysis. Pay attention! I really miss the bad old days when the teachers could throw a piece of chalk at your head or the eraser from the board with the really hard wooden handle, but those days are gone. Now, this is a very, very simple and a very short introduction to mesh current analysis. Now, this is the most simple example you're ever going to encounter. Obviously, it's going to get a lot more complex than this, and there's going to be different cases. For instance, this particular example that I've got here only has voltage sources. Later on, you might be seeing circuits with current sources in them, and you're going to have to find ways around that little problem. But this is just intended as a very simple introduction to mesh current analysis. What is it? Well, the word mesh means to bring together, okay? Meshing together. Now, you might be saying to yourself, well, mesh current analysis, how is this meshing? We're going to see that in a moment. It's called mesh current analysis because we're actually meshing currents together to come to an answer, to understand what currents are flowing in this circuit. Because once we understand what currents are flowing in this circuit, we can understand what voltages are presented at each one of these resistors in this circuit here. So in this circuit here, we've got a 42 volt source over here. We've got a 6 ohm, a 4 ohm, a 3 ohm, and we've got a 10 volt source here. Now the first thing you do in your mesh current analysis is you assign currents to each of the meshes. Now a mesh is just a loop, okay, that has no other loops inside it. So you can see here, if we go around here, we've got one mesh here and a second mesh here. So a mesh here and a mesh here. Okay, so two meshes. Now, if you have a loop, okay, and then there's another loop inside it in a circuit, so you might have a resistor here, and you might have a voltage source here, okay, and then you might have another resistor here. Now, this is a loop on the outside, but it's not a mesh, because a mesh cannot have any other loops inside it, and this is a mesh. So basically, it's going to confuse you a little bit. A mesh can be a loop, but a loop is not necessarily a mesh. Just remember that a mesh has no other loops inside it. So what we do, first step, step one, assign your currents, okay? So let's write these steps over here, okay? Assign currents to meshes, okay? What does that mean? Okay, what we do is we draw, usually clockwise is the favored way of doing it. We draw one in here, see a little arrow here, and then we draw another one in this loop, or see this mesh here, okay? And we're going to give them a value, or a sign. We're going to call one I1, and we're going to call this current I2. So that's step one, assigning the currents to the meshes. Pretty simple so far? Now, step two is we need to apply Kirchhoff's voltage law to these currents. Now, think about these currents that I do need to say, because quite often people look at how this is done. And when I started doing this, I got very confused, because if you've got a voltage source that's maybe going the other way, you might be tempted to make your other current go the other way. Now, when you assign your currents, they all need to go the same direction in each of the meshes, okay? Regardless of what's happening here, because these are not real currents, okay? These are currents that are being used to work stuff out in a circuit, okay? And they are not the actual currents that might be flowing in the circuit. So you need to make sure you apply them all in the same direction, okay? And then when you use algebra and the correct signs, all your answers will be correct. Trust me, people smarter than me and your good selves have worked this all out, and it works perfectly. Okay, so the next thing we're going to do is that we're going to apply, so I'm going to write here for step two. Step two, okay, apply KVL to each loop or mesh. So, what do I mean by KVL? Well, if you don't know what Kirchhoff's voltage law is, you are going to have to go and learn Kirchhoff's voltage law. And it's not that difficult. I will explain it very, very quickly. It's basically the idea that if you go around any loop in a circuit, okay, the algebraic sum of the voltages is going to be equal to 0. Because if you went around a loop and you ended up with more volts than you started with, you'd be creating energy. So it's about conservation of energy. You cannot have more volts appearing than are in the actual circuit, okay? So the way I do this, okay, and it's the best way to do it, I think, is to imagine that you're walking around the circuit, okay? So on this left-hand loop here for I1, we are going to start walking from this corner here, okay? Starting here. So I'm starting at 0. Now, whenever I go from negative to positive, am I going up in value or down in value? It's pretty obvious, isn't it? You're going up, okay? Because if you go from a negative to a positive, you're going up. So my first equation that I'm going to start writing here is I'm going to write 42 plus 42, okay? Then, when I go from here to here, now this current is flowing, I1 is flowing in that direction. So current flows from positive to negative, doesn't it? So if when I'm going from negative to positive, I'm going up, if I'm going from positive to negative, what am I doing? I'm going down. So now I need to say minus. Now we're going to minus the voltage drop that's over this 6 ohm resistor, or across this 6 ohm resistor from here to here. Now, how am I going to work that out? How am I going to know that voltage? Well, I know that I've got a current flowing through here, and what's the current? The current is I1, okay? I1 is going around this loop, and we know through Ohm's law that voltage is equal to current times resistance. Okay, so we know that we've got 6, because it's 6 ohms, times I1. So that's our voltage across our 6 ohm resistor. Now, this is where you need to really pay attention. We've got I1 going this way through here, but our 3 ohm resistor in the center of this circuit also has I2 going in the opposite direction. So we know that we're going to have a voltage that's our resistance times the current. So first of all, we're going to write, and we know that we're going from, this is from positive to negative, and this is going to be from positive to negative for this I1. So what we're going to do is, once again, the voltage is going to be a drop, so it's going to be a minus, and we're going to write our resistance, 3, and our current. Now this is where things get a little bit more complex. It's going to be I1 minus I2. And that is because I1's going this way, down, but the I2 is going in the opposite direction. So that is our first equation, but it's not in the form that's going to be useful to us to solve, okay? So we need to simplify this algebraic expression. So what we're going to do is we're going to expand this. So we're going to say 42 minus 6I1 minus 3I1 plus 3I2. And the reason why we do that is because a minus times a minus is a plus. Simple algebra, which I always get wrong. So now we need to group our like terms. So we've got 6I1 minus 6I1 minus 3I1. So how many I1s have we got? Minus 9I1. And we've got how many I2s? We've got plus 3I2. And I'm going to take my 42 over here, okay? I'm going to take it over the other side of the equal sign, and I'm going to make it minus 42, okay? So that, ladies and gentlemen, is going to be our first equation, simultaneous equation, that we're going to use to work out what the currents are. But we have two unknowns, so we need to make another equation, don't we, to find our solution. As you're maybe aware, I am the lunatic painter and I love art, and that's why this channel is called The Art of Engineering. And in my previous incantation, I was an art teacher, and I still continue to do that on occasion, and I really love the things that art will bring to your life. So please, I know I sound like I'm proselytizing like some sort of priest or something, but give art a go, especially the fine art of painting, because you will see the world in a completely different way. So give me 2 minutes of your time to introduce you in each of these videos to one painter. That's probably going to be a total of 3 minutes out of the entire video, and it will enrich your life. I will put links down below to more information about this particular artist we're looking at. The artist we're looking at today is the marvelous Lucian Freud. Now, a lot of this information is coming from this wonderful book called Freud at Work, and I will put a link in the description below to this wonderful book. It's got some great images. Now, Lucian Freud, he was born in 1922 in Berlin, Germany, and his parents fled Germany to come to the UK due to Nazi persecution, World War II. And he was a man that really lived his life on his own terms, and you can tell by this image here that even into his advanced age, he was a very spry gentleman. And he's famed for his womanizing. He's rumoured to have fathered as many as 40 children, although the stats tend to favour the figure of 14 with a number of wives. And he's most famously the grandson of Sigmund Freud, who is the father of psychoanalysis and the theory of the subconscious. Now, one thing that Freud is very well known for is his affinity with animals. In fact, people that met him said he had a very animalistic type of quality to him, the way he breathed, the way he would stare. And here he is playing with a pet fox. He also loved horses, and he did a lot of paintings of horses, of dogs, and animals in general. He was very fond of animals. When he was at school, he spent a lot of time in the stables. In fact, he spent very little time actually learning his formal lessons and spent most of his time with the stable hands and learning about horses, and he felt a great affinity with animals. Here are some more images of animals and Freud painting a horse in this instance. But his main subject matter was the nude, and he tended to paint friends and relatives and people that he knew because he was an intensely private man. Now, Freud was an amazing artist, but he was also an amazing gambler. Freud was well known for going to gamble at the races, the horse races, and he would lose literally millions and millions of pounds. In fact, one of his art dealers, decided to help him out because he thought, well, he's got a lot of debts. I'm going to try and help him out and bail him out of this situation. And when he went to see the bookmakers, he was told that Lucian was up to, I think it was £2 million in debt at the time. So what Lucian would tend to do was gamble until he lost all his money, and then he'd return to the studio to make more paintings and make more money. Now, eventually, this game that he would play lost its appeal because he was making so much money from his paintings that he couldn't lose it all. It was just too big a task. So he then really committed himself to painting and creating the huge body of work that we see today. He died in 2011, like I was saying, at the age of 88, and he painted for 60 plus years and was an amazing artist. So now we need our second equation. And our second equation is going to be derived from loop I2. So what we need to do is we need to do exactly what we did in the first loop. So we're going to start at a similar point down the bottom here. It doesn't really matter where you start as long as you march all the way around the loop. Okay, but we're going to start at a similar point, and we're going from here to here, and our predominant current for this loop analysis is I2. So that's the one that we're going to say is positive flow. Okay, so we're going from here to here, plus to minus. If we're going in this direction, plus to minus, we know that we are going to do what? Are we going to add or subtract? Well, we're going from a positive to a negative, so we're going down. Okay, positive to negative is going down. So what we're going to end up with is our voltage times our current. So we know we're going down. So for equation number 2, we're going to have minus 3, because it's 3 ohms. And remember that voltage is current times resistance. So now we need to work out our current. We know our resistance. So we know that we've got I2, and I1 is coming in the opposite direction. So for this one, we're going to say I2 minus I1. Now I got a little bit confused about this the first time I did it, because in this one we're saying I1 minus I2, And for this one, we're saying I2 minus I1. Well, that's because in this one, our predominant current was I1, so it's going to go first. Okay, so just remember that. So this is I1 in this loop here, it's I1 minus I2. But when we're going here, we're going I2 minus I1, because now we're dealing with I2. That's the most important current. Okay, so that's our first one. We know it's minus because we're going from plus to minus. Then we're going this way, and our 4 ohm resistor only has I2 running through it. Okay, so in this one here, we're going to say, and we're going from plus to minus again, so it's minus again, we're going to say minus 4 I2. Now, we get to our 10 volt source, and we're going to say, well, do we add, do we subtract? Well, on this one here, we were going minus to plus, and minus to plus is going up. This one here, we're going minus to plus. So we're not going down. Here we're going plus minus, here we're going minus to plus, so we're adding, okay? Whenever you're going minus to plus, you add. Whenever you're going plus to minus, you subtract when dealing with this conventional clockwise current here. Okay, so we're going to say here, plus 10 volts. 10 volts. Okay, so now we need to reorganize this equation in a form that's going to be the same as this one here. Okay, so this is where algebra can get you in trouble, because if you get a positive or a minus wrong, the whole equation's wrong. Okay, and this is the second time I've done this part of the video, because I got it wrong, because I'm algebraically challenged. Okay, so we're going to say minus 3 I2, because minus 3 times I2. Okay, then we're going to say minus 3 times minus I1 is going to be plus 3 I1. Then we're going to go minus 4 I2. And I'm going to already start this equation in the right direction by saying equals, instead of saying equals 0, I'm going to take this plus 10 and move it over the other side, because this all equals 0. Okay, I'm going to take this over the other side, it's going to become minus 10 volts. Okay, because we subtract 10 from this side of the equal sign, we've got to subtract 10 from this side. So we're heading in the direction of an equation that's going to make a little bit of sense. Then we've got minus 3I2 minus 4I2 becomes minus 7I2. Okay, and what I'm going to do, okay, we'll do this. Plus 3I1 equals minus 10 volts. But of course, we don't need to put the 10 volts, so we're just minus 10. We need to get these in the right order, because I1 needs to come first. So we're going to say 3 I1 minus 7 I2 equals 10. Okay? And that is going to be equation number 2. So now we've got 2 unknowns, and we have 2 equations, so we can solve. Algebra, you've got to love it. Now, this is about the 19th time I've done this video, because when I moved this equation up, I didn't put a negative sign here. That's how easily you can get it wrong. That's how easily I get it wrong. Okay, so I moved the equations up. So we've got 2 equations, we've got 2 variables, so we can now solve. Now, you could use matrices to solve these simultaneous equations. You could use the substitution method. In other words, get I1 in terms of I2 and then plug it into this equation. But we're going to use the subtraction method, because we can multiply this equation number 2 times 3. Now you can't always do this. Sometimes you might have to say 3I1 is equal to minus 10 plus 7I2 and get it all in terms of one variable. You divide by 3 and then put it in here. We don't need to do that, because we're going to multiply 2 by 3, and we end up with, if we multiply this one by 3, we end up with 9I1. And then we multiply by 3, we get minus 21I2. And then you multiply by 3, you end up with minus 30. Okay? So now what we're going to do is we're just going to say equation 1 plus equation 2. Sorry, equation 1 plus equation 3. This one here. This is equation 3. So all I did was multiply by 3. Okay, so now we go, it's not I1 as well. So now we go minus 9 plus 9, we end up with 0 I1. Then we go plus 3 minus 21, we get minus 18 I2. And then we go minus 42 minus 30 is going to be equal to minus 72. And now we just need to get this in terms of I2. So we go I2 is equal to minus 72 over minus 18. Get out our trusty calculator, because I am, not only am I algebraically challenged, I'm also numerically challenged. We're going to get minus 72 divided by minus 18, and we end up with 4 amps. Okay, so now we know, slide over here, that I2 is equal to 4 amps. Half the problem solved. More than half the problem solved. So now we have I2 equals 4 amps. We just need to plug it into either of these equations to work out what our I1 is. Okay, so I'm going to plug it into equation 2 here. So we can say 3I1 is equal to, 3I1 minus 7 times I2, we know I2 is 4, positive 4, is equal to minus 10. Okay so far? Then we're going to say 3I1 minus 28 equals minus 10. We need to get rid of this minus 28, so we need to add 28 to this side. So we're going to say 3I1 equals minus 10 plus 28. Brain's getting tired. Is equal to minus 18. Okay, and then we go I1. We need to get rid of this 3. So we just divide by 3 on both sides. So we get minus 18 on 3, which equals minus 6 amps. So that gets us an I1 value minus 6 amps. So we have solved our first mesh current analysis. So let's go through the steps you need to do. First thing you need to do is assign your loops, 1 and 2, or however many loops you have. Now if you've got 3 currents, you'll need 3 equations. If you've got 2 currents, you need 2 equations, etc., etc. Then you need to apply Kirchhoff's voltage law, noting whether you're going from negative to positive, in which case you add the voltages, or positive and negative, in which case you subtract. Then you build your equations, like I just did in this video, and then you solve them. And that is mesh current analysis. Hope that's helpful. Please like and subscribe. Leave a comment below if you've got any questions. And I have done this because I'm doing this presently in my engineering degree, and I'm not the best person when it comes to mathematics, especially being careful about algebra and whatnot. So you will find practice will make perfect.